let me introduce our first speaker. First speaker is Tony Firenzi of the Placer County Water Agency. Tony is an engineer, but he's much more than an engineer. He spent a career working on rivers, on riverine issues, on water supply projects, and he's often worked with environmental stakeholders and worked towards collaborative solutions. Most recently, Tony was part of a team that did some groundbreaking work on downscaling global climate data, global climate modeling data, and applying them to the American River watershed. And he's going to talk about that today, as well as talk about some progress on some climate resiliency projects that he's working on. So please welcome Tony Firenzi. Tony.
Thank you, Tom, for that great introduction. Let me just check first. Am I coming across okay? I am good. Thank you. It's an honor to be on the panel today, so thank you very much for that opportunity. Also, congratulations on 20 years of success, 20 years of collaboration, and 20 years of progress with the Water Forum. I think you and the whole team, everybody probably on this event deserves to celebrate with what we're doing today. So it's truly an honor again to be part of it. I'm going to be presenting the American River Basin study. This is a study that predicts climate change and the climate change impacts to our watershed. As water managers, what we're looking for is long-term solutions to adaptation. So before I move on, I'd like to thank the U.S. Bureau of Reclamation. They're the ones that actually led this effort. They were fantastic to work with. I'd like to thank their Technical Services Center, their consultants, and last but certainly not least, we have local cost share partners. All these people made this work happen, so I'd like to thank all of them. Before I actually talk about the American River Basin study, I'd actually like to take us back in a time to a previous Sacramento water problem. In the early 1900s, the people of Sacramento received their water pumped directly out of the river, unfiltered, to their homes and businesses. The water was full of sediment, and pathogens were attached to that sediment. Typhoid, cholera, and dysentery, unfortunately, were not uncommon back then. And sadly, it wasn't uncommon to know of somebody who would have died as a result of these diseases. Next slide, please. Oh, thank you very much. After decades of complaints, the people of Sacramento finally banded together. They approved a $1.8 million bond to construct a filtration plant on the Sacramento River. Amazingly, this was the first municipal filtration plant west of the Rocky Mountains. Next slide, please. This is a photo of the river intake that led to that filtration plant. I think the people of Sacramento back then and even today should be proud of and find hope in the fact that that they were able to come together and invest in something so fundamental to a healthy way of life. They built a filtration plant 50 years before those things were required by the Clean Water Act of 1972. They were really ahead of their times. Today, we have a similar call to action. Climate change is threatening our water supplies right up at the source, sometimes, in some cases, before the water even falls from the sky. We have solutions, and I'm happy to present some of those solutions to you today. But before I go there, I'd like to describe our watershed and then describe the problem to you. Next slide, please. Thank you. This is our watershed. On the floor of the Sacramento Valley, beneath Sacramento, we have two groundwater basins. There's the North American subbasin and the South American subbasin. And then moving upstream, you see Folsom Reservoir. It's just shy of 1 million acre feet. On the American River system, we have three forks, the north, middle, and south forks of the American River. In upstream reservoirs, we have a scattering of them that amount to about 800,000 acre feet in storage. This watershed receives about 1.1 million acre feet of snowpack each year. There are more than 20 water agencies in the Sacramento area, serving a population of greater than 2 million people. And all of these people count on these water resources for their current way of life. But in addition to that, you'll notice on this slide, the lower American River. It's the portion of the American River below Folsom Reservoir. It's home to many species, but two in particular. fall run Chinook salmon, and steelhead count on that cool water coming down from that snowpack through Folsom Reservoir to sustain their way of life. Next slide, please. 64 climate models predict for us that we can expect about 6 degrees of warming by 2085. For some of you listening, that will be within your lifetime. That really kind of brings it close to home, I imagine. As a matter of comparison, we just wanted to see what have we seen so far. We found a weather station, a high elevation weather station in Blue Canyon along the North Fork of the American River. It's up at about a mile high along Interstate 80. And that weather station had data going back to the mid part of the last century. And what we see with that data is that over that 70-year period, we have already seen about 3 degrees of warming. So we've already warmed about half of what we can expect in the future. That same data reveals to us that days of freezing weather are expected to go from 110 days per year down to 70 days per year. That's a 36% decline in freezing days up at a high elevation. Next slide, please. This slide presents a snowpack across California in contrast of 2 years, February 2018 to February 2019. The point of this comparison is just to illustrate what does California look like with the loss of snowpack that we might be anticipating. In the Basin study, we're actually not seeing results that show a significant loss of total annual precipitation. Instead, what we're expecting is that precipitation will be rain instead of snow. Snow as a percent of precipitation is expected to go from 20% all the way down to 5%. But the real number that scares me, we will suffer a loss of snowpack in the range of 50 to 75%. I think that's an expectation that probably concerns all of us. Next slide, please. We saw what this loss of snowpack looked like back in the drought of 2014 and 2015. Not only is this a threat to our water supplies, but the increased intensity and frequency of heavy rains in the earlier part of winter can only mean more frequent and more catastrophic flooding. And expectations on the lower American River for river water temperatures going up are expected to go to levels that are not survivable by our endangered fish species on that river. I think it would be a real failure of adaptive management. And as a water manager, I think it'd be a failure on our part if we were just to accept living in these kind of conditions without adapting, without response, or without doing our best. So we have before you today a lot of great ideas, but ultimately what all these great ideas need is us working together. Next slide, please. Again, this is our watershed, but we're looking at things a little bit differently in modern times now as water managers. We're not looking at our purview over this situation as just being contained within where water is consumed in and around the urban and suburban part of Sacramento. We're looking at the entirety of the watershed. So we have lots of great ideas, like the Sacramento Regional Water Bank or the River Arc Project. The River Arc Project will take diversion pressure off of the sensitive portions of the lower American River and shift them over to the Sacramento River. We have water use efficiency programs, flow and temperature management on the lower American River, forest health and forest management, upstream storage enhancements and optimizations, and floodway improvements. These are all integrated solutions that need to be thought of together. We're calling this the supershed. Go ahead and say it. We're calling it the supershed. I'm not going to be able to talk about all of these today. I have two in particular. I'm going to be talking about the Sacramento Regional Water Bank and forestry management. But you can check all of them out. They're all on the Regional Water Authority's website. I have it shown there, rwah2o.org. Before we move on from this slide, what I'd like to emphasize is the point of all of this is trying to arrive at the co-equal goals of the water forum, even in spite of climate change. Next slide, please. Pcwa owns and operates a hydroelectric power system in the Middle Fork of the American River. Shown here is French Meadows Reservoir and Hellhole Reservoir. They're on the north tip of what was, or what actually is, the burn area of the King Fire. Not only do we occupy this portion of the watershed for this power system, but we also rely on this portion of the watershed to be healthy for our downstream needs of the water. In 2014, the King Fire swept through. It felt like it was almost overnight, and it scalded the landscape, almost 100,000 acres of this watershed. At that time, we thought this was a mega fire. It really felt like the biggest fire we had ever seen. Looking back at historical fires, the biggest one we had seen in this watershed up until that date was 25,000 acres. But the reality is, most of the many other fires we had seen in this watershed were much, much less than that. Here we are, 6 years later, and the kind of fires we're seeing right now, they almost trivialize the King Fire, which is kind of a scary thought because I remember how I felt back in 2014. I think last year we experienced about 4 million acres of fire in California. And this year, I think we've doubled that at about, I think last year was 2 million, and I think this year we've doubled that at 4 million. And yes, we hit our single biggest record fire this year at 1 million acres. Next slide, please. This is a small reservoir just a few miles downstream of the King Fire burn area. You can see that it's laden with sediment. The sediment isn't good for our power facilities. It's not good for our water supply, and I'm quite certain it's not good for aquatic habitat. Since the King Fire, PCWA has had to spend more than $5 million cleaning out sediment from this site. Next slide, please. This is the confluence of the North Fork and the Middle Fork of the American River. This photo was taken just after the ash and sediment began washing down from the hill slopes of the King Fire. Notice the color difference in the two sources of water. It's pretty stark. It is issues like these and those on the previous slides that got PCWA inspired to get engaged in forest health. Next slide, please. This is a map of the waterway that connects our French Meadows Reservoir with Folsom Reservoir. Also shown is highlighted in yellow is the watershed around our French Meadows Reservoir. PCWA has embarked in partnership with Placer County, the U.S. Forest Service, and the Nature Conservancy on a collaborative process for restoring the and rejuvenating the watershed in and around our French Meadows Reservoir. I should probably clarify, this isn't a King Fire burn area. What we're doing in this watershed is clearing out decades of underbrush growth so that we don't have another mega fire right over the top of our reservoir like we did before. Down in the detail below, you see the work that we plan on doing. Shown in blue is areas proposed for mechanical thinning, and in red are areas proposed for controlled burns. In total, this will be about 20,000 acres of treatment of land. My understanding is that by the end of this year, we will come close to treating 4,000 acres. This is a pretty long-term project. It's going to cost about $17 million and expected to take about 4 years for the extent of mechanical thinning. And the expectation is that the controlled burns will probably go well beyond that. Next slide, please. This is a before and after shot of the kind of work that's being done up there. Look to the left, and then notice in the photo on the right that after the treatment, you can see our French Meadows Reservoir, the clouds and the sky through the trees. My understanding is that on average, we're reducing tree density from about 500 trees an acre to about 50 trees an acre. That was really a stark number when I heard that. That's an order of magnitude. There's a lot of science that goes into which trees to remove, and it's important that's why it's important to have knowledgeable decision makers on site when the work is taking place. That way the work gets done expediently. Next slide, please. This is a meadow that was identified and overgrown. It was identified by Tahoe National Forest. And once they noticed it, and they took on a project to restore it, and so you can see the work is underway here. The reason I showed this is that I wanted to say that we've identified 23 sort of overgrown, abandoned meadows in our French Meadows watershed. Imagine that, 23 meadows in French Meadows. And this is the kind of work that we'll be looking at within our program. Next slide, please. Now I'm going to shift gears to the Sacramento Regional Water Bank. Excuse me, this is, I'll just have to admit right up front, this is probably the most complicated part of my presentation, so bear with me. I'm going to take it slow and easy here. Shown on this slide, you see 3 sources of water storage on the ground. So we have Snowpack, as I've talked about before. We have the north and south groundwater basins, and then we have Folsom Reservoir. I've talked about how we expect most of that snowpack to go away as a result of climate change. And so the proposal for the water bank is to make up for that loss of snowpack in the form of groundwater storage. That's essentially what water banking is, but it's a little bit more complicated than that. The way that it works is that water agencies that are currently on groundwater would shift over to surface water when it is abundantly available in those heavy, wet years. Those times would allow that groundwater basin to replenish and fill up. And then when we have dry years, those agencies would go back to groundwater, and actually agencies that normally serve surface water would do provide some of their water off of the groundwater as well. So basically in dry years, they would be utilizing the reserves of groundwater that they had put in the wet years. And the way I look at this is that we're shifting how we operate in the cycles of the water system. With snowpack, you're cycling essentially between seasons of snowpack accumulation in the wintertime to seasons of snow melt in the summertime. With groundwater banking, what you're doing is cycling between wet years and dry years, essentially. Next slide, please. The point of this chart is just to show you our current reliance on snowpack. I've mentioned before, we typically get about 1.1 million acre feet of snowpack. That constitutes 38% of our above ground storage in million acre feet. It would stand to reason that, that we have a very vulnerable situation here if we're losing most of that snowpack. Let me show you what that looks like. Next slide, please. So this is that same chart, but with the expected loss of snowpack removed. You see there climate change is shown as removing about 800,000 acre feet of snowpack. Shown there is 0.8 million acre feet. That's a 29% loss of our total above ground storage. But notice that 800,000 acre feet can be well made up in the below ground storage of the aquifer. You see down below where we say that that aquifer has storage space available of 1.8 million acre feet. So from the bottom line of a ledger, it actually works. It's just a matter of implementation. Let's go to the next slide. Implementation is actually easier than explaining how this works. Implementation really involves all of the agencies in the Sacramento area working together. We need to plumb our systems together with interties, and by doing that, those that are on groundwater can take advantage of surface water in wet years, and those that are on surface water can take advantage of groundwater in dry years. Also needed are some groundwater well improvements. We plan on using both downhole injection and in-lieu recharge. And for those that may not know, in-lieu recharge is simply allowing the aquifer to fill up naturally during wet times. Next slide, please. It's been 100 years since the people of Sacramento invested in their own health by building that filtration system. Their needs for water were quite one-dimensional back then. It was all about public health and, frankly, survival. It's a bit ironic, perhaps even peculiar, that 100 years later, I think the vulnerability of public health is probably apparent to all of us. So we can probably appreciate what they might have been going through, perhaps even scared to drink the water back then with pathogens. I think it's well recognized that the needs for water are much more complex, or recognized as being much more complex in this day and age. I'd like to capture that complexity in 3 words: environment, economy, and humanity. Next slide, please. The Sacramento region is well ahead in adapting to climate change. I think we're well ahead compared to most areas. We've got a firm grasp on what we can expect. Unmitigated, I think we can expect a future of flood, fire, and drought. But I'm hopeful. And the reason I'm hopeful is because people are working together. We have these great ideas in the supershed, things like the water bank and forest health. But more important than that, we have people working together. And the Water Forum is central to people working together. So for that, I applaud all of you. And that concludes my presentation. Thank you.